Picture this. You have the Sun and Earth dancing their predictable cosmic waltz. We can calculate their positions with stunning precision using Newton's laws. But the moment you introduce a third celestial body, like the Moon or another planet, everything falls apart. What seems like a simple addition becomes an impossible puzzle that has stumped brilliant minds for over 3 centuries. Here's what makes this so mind-bending. With 2 objects, we have what mathematicians call an integrable system. Think of it like a perfectly choreographed dance between 2 partners who know exactly where the other will be at every moment. The equations balance out beautifully, giving us clean, predictable solutions. But 3 bodies? That's like adding a third dancer who doesn't know the routine. Each object pulls on the other 2 with gravitational force, creating a web of interactions that become chaotic and unpredictable. The system becomes what scientists call non-integrable, meaning there's no general formula that can solve it exactly. The French mathematician Henri Poincaré essentially proved this impossibility in the 1880s while working on a problem posed by the King of Sweden. He discovered that tiny changes in initial conditions could lead to dramatically different outcomes over time. This was actually one of the first mathematical descriptions of what we now call chaos theory. Think about what this means for our solar system. We have 8 planets, dozens of moons, and countless asteroids all pulling on each other. Yet somehow, this apparent chaos has remained stable for billions of years. How is that possible? The answer lies in something called restricted solutions. While we can't solve the general 3-body problem, we can find special cases where things work out. These include situations where one object is much smaller than the others, or where objects are arranged in specific geometric patterns. Scientists have discovered fascinating solutions like the figure 8 orbit, where 3 equal masses chase each other in a pretzel-shaped pattern, or Lagrange points, where a small object can remain stable relative to 2 larger ones. These solutions are like finding perfect notes of harmony within mathematical chaos. Modern space missions actually exploit these principles. The James Webb Space Telescope sits at a Lagrange point, using the gravitational balance between Earth and the Sun to maintain its position with minimal fuel. We've learned to work with the 3-body problem rather than solve it completely. This unsolvable puzzle teaches us something profound about the universe. Not everything can be reduced to a simple equation, even when we understand all the underlying physics perfectly. Sometimes, complexity emerges naturally from simple rules, creating beauty in unpredictability. The 3-body problem remains unsolved, not because we lack the mathematics, but because the universe itself has built-in limits to predictability. And perhaps that's exactly what makes it so fascinating.